Hello, everyone. Hello, everyone, and welcome today on the second module of the environmental assessment and circular economy. Second module will be focused on carbon footprint and, of course, how to measure it and how to reduce it. We will be dealing with some basics on how to calculate carbon footprint, what is carbon footprint, what causes carbon footprint. Then we will try to calculate it and assess it for ourselves. So we will do individual assessment by two different web calculators. And then in the second part, we will focus on digitalization as one of the most intensive trends of global economy. And we will try to, I will try to show you how much also digitalization impacts on carbon footprint, and how individual activities like taking photos with a smartphone or something like that can cause carbon footprint and why this is so important to reduce it. So hope you will enjoy it. My name, as mentioned, is Mateusz Obrecht, and I'm the professor at Faculty of Logistics, dealing mainly with sustainable supply chain, sustainability research, energy supply, eco-design, and environmental protection. So this course, as previously discussed, is about environmental assessment, one part, about circular economy, second part, and of course how to motivate people to live a little bit more sustainably. So if we start with environmental impacts of industry, companies, organizations, people, individuals just like us, what kind of impacts do we cause and what do we know about them? So we mostly talk about emissions. So greenhouse gas emissions or any kind of emissions in the air, in the ground, in the water are the most media covered negative impact on the environment, which is not the only one we should be aware of. So emissions in the air are very visible, so we are very much aware of it, and we of course want to reduce them. However, we must be aware that there are additional negative impacts on the environment, such as, for example, energy use. We use too much energy, which is based mainly in the fossil fuels. Approximately 85% of global energy is produced out of fossil fuels like coal, oil, gas, and so on and so on. Then another negative impact is, of course, the noise pollution. So if someone is doing something about, road construction, building, production facilities, if you have one big industry facility in your neighborhood, what happens? Noise pollution can impact local habitat. It can impact human health. It can also impact value of your real estate because nobody wants to buy real estate close to the industrial facility, and so on and so on. So it's also a negative impact that causes environmental and social impacts. Then another one is light pollution. When humans developed and when we developed a very intensive, energy-intensive economy, we also enlightened the sky. So we have a lot of bulbs that don't light up only the streets we want. They don't light up just the backyards or the production facilities or whatever we want to enlighten, but also it enlightens the sky, it enlightens the natural habitat, and the trees that are growing in nearby trees that are growing in the cities has proven to be less resilient to some harmful diseases, and therefore they they have shorter life. It also causes it also causes sleeping problems, and therefore it also impacts the human health. Another one that we don't talk that much about is the land use. So here on the figure, on the picture, I have the solar power plant. You can see that the solar power plant is installed in the desert. So let's say the area where we cannot do much, and it is therefore wise to use it for the solar PV, so for the energy production. However, if we are installing photovoltaics on arable land, we can reduce carbon footprint, of course, because we will reduce the use of fossil fuels. That's why there will not be any harmful emissions in the air from the fossil fuels. But on the other hand, we will reduce the capability of humans to produce food. So that's why on the arable land, installations of photovoltaics is really against common sense, and it should be done on a different way. So maybe with some dual use of the land, so land that can be used like where that could be used for farming and for photovoltaics. That's a great opportunity, but we must be aware that sometimes too extensive land use is also a very big impact on the environment. Of course, the one that we see most in everywhere where we live, everywhere where humans are present, is the material use and huge amounts of waste. So once again, another environmental impact. So we can do much about that. We have numerous possibilities how to reduce these impacts, and I will show you just a few of them. So for example, if we want to reduce the emissions, like I mentioned, I'm a professor for supply chain management, so I'm dealing mostly with the supply chain management and logistics facilities. So we have a business facility that uses, for example, 2,000 liters of heating oil for heating their business facilities. So I don't know, warehouse, production, or offices. This causes quite a significant impact on the environment. It causes huge amounts of emissions. So what can a company do to reduce it? Well, one of the ways is to replace the heating oil with natural gas. If we replace it with natural gas, we can reduce the emissions for 1 ton and 360 kilos. So huge reduction of emissions, and we didn't do much. We just went from heating oil to natural gas. Both of them are fossil fuels, but we can see that also dividing fossil fuels and replacing cleaner fossil fuel, replacing technologies for cleaner fossil fuels can be very beneficial from the environmental perspective. If we are a little bit more ambitious and we don't want fossil fuels, we want to get rid of fossil fuels. If we have, for example, if we are eligible for the European Union taxonomy, for example, or we have a strategy to be net zero carbon company, we can go, for example, on heat pumps. So if we replace natural gas by the heat pump, we can do much more. So that means we can even decrease the emissions by almost 2.5 tons of CO2. So heating oil 2,000 liters, we get rid of it, we install a heating pump, which is powered by the electricity. We can reduce carbon footprint by up to 2.5 tons. Of course, it depends where the electricity for heat pump comes from. So it depends whether we have our own PV, whether it comes from hydroelectrics or some other, let's say, not that favorable energy source from the environmental perspective. The second one we talked about is the energy use. Of course, the energy use is extensive. If we want economic development, we need energy. For everything what we produce, everything what we grow, everything what we do, we need energy. We need electricity, we need heat, and so on. But we can get this on numerous different ways. And if I divide it on 3 types, we must be first aware that renewables are a solution. There are very good solutions, but solar, wind, etc. are not stable, are not completely the same in all of the times of the day, all the seasons of the year. So when the sun is shining, we have a lot of electricity. When the wind is blowing, we have a lot of electricity. But when at night, in the winter, or when there is no wind, we cannot have sufficient amount of electricity. So we still need different solutions. We forget many times that even if we keep up with the fossil fuels as a, let's say, short-term or mid-term solution, not a long-term one, but we can do big improvements also in the fossil fuels. So this is a picture of so-called cogeneration. Cogeneration actually means to produce heat and electricity at the same time. So all those big power plants that produce electricity and are powered by coal, by oil, by gas, for example, those power plants are approximately 30 to 40% efficient. So it depends on the technology. It could be up to 40 to 42, 43%, but this is like a theoretical maximum. All the rest goes in the air. So all the rest is the waste energy. So what about if we would somehow be able to do something efficient with that waste energy? And this is the idea of cogeneration. So creating electricity and heat simultaneously, that means that we can increase efficiency from 30 to 40 up to 70 or even 80% in theoretical cases. So this is the way how to, let's say, double efficiency of use of fossil fuels. So if we talk about doubling the efficiency of fossil fuels, we come to the, let's say, we come to the third picture, which is the energy pyramid. So the energy pyramid clearly shows you what should be the priority, what should be the second step, and what is the last step. So as we can see, energy conservation and energy efficiency should be the backbone of every energy supply, whether we talk about global, national, local, or just on the level of an individual company or individual household. So if we want to replace all the fossil fuels by renewables, we must be aware that we don't have sufficient amount of planet Earth. If we keep up with the increasing demand for energy, if we keep up with the increasing consumption of energy, electricity, and so on, we will not be able to install sufficient amount of renewables in the future. So that's why we must be smarter and we must conserve the energy. We must get rid of those energy consumers that we don't need them, that they don't bring any additional value, and we need to spend energy wisely, efficiently. So like in the case of, for example, like in the case of cogeneration, like in the case of smart grids, like in the case of installing batteries for stabilizing energy supply and demand and so on. And of course, you can see the top of the energy pyramid is up here with colored green, and this is the part where we can put renewable energy on it. So the top of the energy pyramid are renewables, and of course renewables are the solution, however not the only solution. It must be viewed from a systematic approach, and we must do 3 measures. So conservation, keep up with energy efficiency improvements, and installing renewables. Then we talked about the noise pollution, like construction, industry, or whatever it is. We have different solutions. So from the perspective of logistics, we have, for example, in Germany, we have some kind of a Umweltzone, which means environmental zone. So this is a zone where you cannot drive with, for example, older cars. You cannot drive with cars that cause too bigger pollution. You can have also like for example, some limitations about speed. So you have a speed limit during the night. So during the night, the speed is reduced so that the tire fraction, engines, and so on will not produce so much noise, and we will be sleeping better. Then we have also like physical obstacles, or let's say physical barriers that try to decrease spreading of the noise. So this is basically mainly done on the highways and so on. So these are just a few solutions. For example, light pollution. Once again, we can see on the right-hand side we have the bulb and the lighting from the old times. On the left-hand side, we have newer bulbs and newer lighting that are focused only on the sidewalk, for example, or on the road. We can see the difference also here. So on the left-hand side, the orange, yellow, or orange color, which is on one hand better for if it causes less pollution than the white one, but you can see the sky up above. You cannot see the stars. On the right-hand side, you can see the stars. The sky is black. The road is much better. Is much brighter. So you could read newspaper on the road. So this is one of the ways how to do it. But if you install much stronger bulbs and focus bulbs, you can reduce light pollution to the sky. You can increase you can improve the safety on the roads, but maybe in these cases it would be also wise to reduce the number of lamps, number of bulbs on the street. So how the legislation developed, here you can see from the very bad towards bad, where we had like a cap on the top so that the light couldn't go up to the sky. Then it was this was additionally improved so that the angle of the lighting was 180 degrees, so horizontal to the surface. And now we have the last one, which is focused to where we need the light. So you can see here we have much better lighting and much less pollution. We can see the sky again. Then we have the land use. So we were talking about the land use. Here you can see the case of, for example, combination of photovoltaics and farming. So we can use land, for example, for farming, for maybe sheep or something like that, and we can produce electricity. Otherwise, it is much wiser to put it on the roofs or to put it on some degraded areas and not spending the arable land, which must be focused in producing food. We also talked about the material flow, about the wastes, and here you have one great solution of how to do it. Of course, we can compost, we can recycle, but recycling itself is not such a good solution for the environment because it uses a lot of electricity, energy, it causes big environmental impact. So not recycling, but we should focus on upcycling, reusing, reducing the quantity of the wastes, and so on. So here we have one case of the upcycling. It is the case of the frightened bags, which is also very commonly presented in the sector of logistics. So it is actually an idea of two individuals from Switzerland who were thinking about creating a product that would be more sustainable and created from waste. And they found out that, for example, these car tarpaulin, truck tarpaulins, are very, very resilient. However, transportation companies are replacing them from time to time because they get used on a part of the car tarpaulin, but the majority remains completely, let's say, not intact, but very, very, very functional. So they use this truck tarpaulin. They have washed it, cutted it on the pieces, sew it together, and created a bags like this, which is created out of car tarpaulin, out of used seat belts, and out of used tires, or used tires from the bicycles. So a product made completely out of waste, and the product which can also achieve high prices on the market. So this kind of bags really are a good case of upcycling and not just recycling. So all of this, we can see there are numerous environmental impacts that are being caused by the humans. There are solutions, of course, and all these impacts are being caused within the whole supply chain. So not just on the level of the customer or final user, but within the distribution, packaging, transportation, warehousing, production, getting the raw materials, for example, getting the supply, and so on. So the whole supply chain is actually giving some negative impact on the environment. We talked on the previous lectures also about the carbon cycle. So the carbon cycle is a very tricky and a complex thing. So within the, let's say, tens of thousands of years when humans are being present on the planet Earth, the carbon level of the carbon dioxide has changed. However, all the times there were some emissions of carbon dioxide, the natural emissions of carbon dioxide, because of the, for example, forest fires, because of the volcanic eruptions, and so on and so on. So there were huge emissions also in the past where humans didn't burn fossil fuels. On the other side, there were carbon sinks, like oceans, seas, for example, coral reefs, forests, and all the green plants, for example, that need actually carbon to grow. And then humans appeared. And at the beginning, we were using only wood. Wood is the basically also made of carbon, and is also emitter. When we burn wood, we also emit some CO2 emissions. However, these CO2 emissions can be equal to zero because the carbon was stored in the wood when the tree was growing, and when we burned it, actually we released it once again. And that means that this carbon cycle was, let's say, more or less closed, didn't have any interruptions or any, let's say, any increasing values or decreasing values, or increasing increasing significantly. In the millions of years before the humans even were walking around the planet, all those forests and so on were during the millions of years converted to coal, oil, gas. So all of this is actually carbon capture and storage, let's say somehow some warehouse of the carbon, which was covered by the sea, by the rocks, by land, and so on. So it was stored inside the planet Earth. And what happened next? In the Industrial Revolution, humans started to dig out coal. Later on, we started to pump oil and gas, and we released this stored fossil fuels. We released this stored carbon from beneath the ground into the air. And this is where the carbon cycle got broken. Concentrations of CO2 started to increase. And what we are facing now is that we are having too big emissions of CO2. And on the other hand, because of the overpopulated planet, because of the deforestation, because of urbanization and so on, we are having less forests and we have bigger emissions of CO2. So that means that the carbon cycle is being broken and is not, planet Earth is not able to regenerate itself. So that's why the concentration is going higher and higher. This is of course not good because this is in the scientific field accepted as the main cause of climate changes. So bigger concentrations of carbon emissions are causing climate changes. So what climate changes are, we talked about that also on our previous lectures, but just to briefly go through, the climate changes are not just changes over the climate or heating the environment for 1 or 2 or 3 or 4 degrees in average. These climate changes could also cause sea level rises. It could cause drought. It could cause marine ecosystems to change, to many plants and animals to die. So it will have huge effect on the ecosystems. It would cause melting glaciers. So millions of big amount of drinking waters will be at risk. That's why we will have water shortages, and availability will be further limited in the future. So river flow will be reduced, mainly in Mediterranean, in Southern Africa, South America, and we will have a lot of forests because of higher temperatures, because of less frequent rains, because of not so cold winters, and all of these will cause heat waves. Heat waves and extreme weather conditions will be much more frequent, and this will also cause, once again, impact on human health. However, it is not just the human health which I'm concerned about. We will also face food shortages because of deforestation, because of the desertification, because of the drought, because of water shortages, and so on. We will have less arable land, and we will have agriculture that will have to survive in much riskier environment, much more unfavorable environment. So that means that the food will become more expensive, and probably we will have also food shortages. So if we don't do anything, we will have big problems. We will have big challenges, also not just like individuals, but also like humankind to survive. So to make improvements, we started to think about how to first assess what kind of impact are we causing as a humankind, as an individual, as a company, as a country, as a continent, or as globally as a planet. Here you can see the presentation of global carbon footprint. You have emissions by the nations, and you have, for example, North America light green, Europe dark green, then you have South America brown, Australia and Oceania with blue, then you have Asia orange, Middle East red, Africa purple, Central America you have pink color, and you can see which are the countries that contribute the biggest amount of carbon footprint. As you can see, Central America, for example, Caribbean, not that big. Also, majority of Middle Eastern countries, not that big. On the other side, we have like China and United States, which are being the biggest polluters and biggest contributors of carbon footprint. Historically speaking, the biggest polluter were United States, but recently, in last few years, China surpassed them and is causing even much bigger emissions recently than United States. However, if we calculate emissions per person, China is still way behind United States, and United States are having much bigger emissions per capita. We can see here also all other important emitters like India, Japan, Russia, Germany, Canada, Italy, and so on. It is very interesting, for example, that if we compare Russia, India, Japan, we have on one side population with 120, 150 million people, and on the other side we have India, which has tenfold that big population, and emissions you can see more or less the same as Russia or Japan. So that means that India is having high growing population, but is not so developed economically, and that's why they are having very low emissions per capita. India is still is actually having emissions that Europe wants to have by the 2050. We could say something like this. So where we want to be in the next, where we want to come in the future decades, India is already there because it is not that developed. However, the tricky part is that India is going up and Europe is going down, for example. Yeah, here is also the graphical representation for different countries. You can see, for example, that India on one hand is not having big emissions. On the other hand, you can see the Emirates, you can see the Ireland, you can see UK, Denmark, and on this side of the world you have United States with huge pollution and big footprint. What's the largest source of greenhouse gas emissions? Like for the European Union, here is the representation, and you can see that the majority of greenhouse gas emissions comes from energy sector. So we don't create that much with agriculture, with industry, but mainly with energy sector. So within the energy sector, as you can see on the right side, the biggest part is electricity and heat. So that means electricity and heat for heating the homes, for heating the business facilities, for using it, and so on. Then we have the sector of manufacturing and construction, which also contributes quite a lot because it spends a lot of electricity and fossil fuels. Then we have transportation, which is once again one of the biggest polluters, especially in European Union, because transportation is mainly based on the fossil fuels. We have public transportation like railways, which can be based on electricity, and we are trying our best with electric vehicles. However, electric vehicles are far from being that developed that would be carbon neutral. So now we saw which are the biggest polluters, what are the impacts on the environment. So we are once again facing greenhouse gases, and we are talking about greenhouse gases. But before we saw that it is not just the greenhouse gas, it is also noise pollution, it is also light pollution, it is the land use, waste, and so on. So the basic principle in Europe is to get rid of those negative impacts. So the European Union Green Deal is actually a plan how to reduce emissions by 50%, 55% by 2030, and how to become net zero by 2050. So how to become first carbon neutral continent on the planet Earth. This could be done with sustainable development, reducing greenhouse gases, transition to circular economy, smart and sustainable mobility, renovation of buildings for bigger energy efficiency, and of course, strengthening renewables. So this is not just like environmental policy, it is also very pragmatic because we are importing majority of fossil fuels from different countries like Russia, like Middle East, also something from United States or North African countries. So we are, as a Europe, much more dependent. And if you are dependent by one very relevant resource, that means that you cannot develop completely like you want, but you must consider also your suppliers. And that's why we are facing that many problems, and this is one of the ways how we can get rid of two problems. So we can get rid of the energy dependency, and we can get rid of environmental harm. So it's a good plan. However, we will see how it will go with the implementation. So if we focus on the emissions, so we talked about the emissions, and we have to know that if we want to reduce emissions by 55%, if we want to become carbon neutral continent, we first must be aware how to measure these emissions. So measuring these emissions is one of the ways how we could improve environmental performance, and that's why we are introducing environmental management. In environmental management, or even general management, mostly managers are aware of this statement. So what is not measured is not managed, and we cannot manage carbon emissions if we don't measure it at first. So first we need to know what problems exist. We need to know what are the alternatives, and we need to know what to do. However, if we want to do anything, we must first assess and evaluate environmental impacts. We have to monitor them, and on this basement of assessment and monitoring, we can find alternative solutions and propose the best. The last phase is, of course, implementing it. So if we want to talk about the carbon emissions, of course, we need to be systematic once again. So we can reduce emissions just in the use phase. So just like electric vehicles. Electric vehicles are a very environmentally favorable way of transportation in time of use. So when we are driving electric vehicle, we don't emit any emissions. However, huge emissions were caused when the electric vehicle was produced, and we can cause emissions with production of electricity. So electricity should be from renewables, otherwise electric vehicles cannot be identified as sustainable. So this is the basic idea of life cycle thinking. So we shouldn't talk just about the use phase. We should also talk about how to power something, to use it, how to produce it, what to do with a certain product after the end of life, and so on. So life cycle thinking is about going beyond the traditional focus on production side and manufacturing or use, and including environmental, social, economic impacts over the entire life cycle. So the main goal is to reduce resource use, to reduce emissions, impact to the environment, and to improve socioeconomic performance. This way, we can facilitate the links between economic, social, and environmental division within organization or value chain. We have a lot of environmental texts that are actually showing potential buyers that the product has been assessed somehow. So we have, for example, tagged like compostable. So that means the product is created out of the ingredients, out of the materials which could be composted. We have this FSC or PEFC, for example, Forest Stewardship Council. This is actually the sustainable sourcing of wood, for example, for the paper industry, for the wood industry, and so on. Then we have like this one for textile. So it means that it is made out of organic textile, for example. However, the most relevant are those three here up above. So European Union Ecolabel, Blue Angel, and Nordic Ecolabel or Nordic Swan. All those three labels actually include environmental impacts through the whole life cycle. So they are much more comprehensive. And when product has these labels, it really means that it was assessed comprehensively by assessing different stages of the life cycle. Carbon footprint is also one of the measures which could be used for measuring environmental impacts. But like we mentioned at the beginning, it measures only carbon footprint. So it doesn't matter. It doesn't measure how much water you consume. It doesn't matter if you emit any kind of radioactive elements. If you spend too much land, for example, it focuses on emissions. So it is a method to evaluate emissions of CO2 equivalent of every action or a process. So why CO2 equivalent and what kind of equivalent? Actually, we have numerous greenhouse gases, so like steam, CO2, methane, and the different kinds of others. We will see them later on. And because of the easier representation, CO2 was selected as the basic, currency. So all other greenhouse gases should be transformed in the GWP of CO2. GWP means global warming potential. So the global warming potential of CO2 is 1. Global warming potential of other gases are much higher, and that's why it was used as the basic unit for carbon footprint calculations. Here we can see the representation, and here's the link for the calculator, but I will show you later on how to deal with that. So the greenhouse gases, primary 10 greenhouse gases are water vapor, carbon dioxide, methane, as mentioned, and nitrous oxide. All these are naturally occurring. Then you have perfluorocarbons, hydrofluorocarbons, and so on, that are present in the atmosphere due to the industrial processes. So let's say anthropogenic causes. Water vapor is the most abundant and dominant greenhouse gas in the atmosphere. Its concentration depends on temperature and other conditions, so not directly just upon human activities. On the other hand, CO2 is the primary anthropogenic greenhouse gas, accounting for approximately 2/3 of the human contribution to the greenhouse effect. So that means also the most important one, the gas with the biggest quantity actually in our atmosphere, talking about the greenhouse gases. And global warming potential indicate the relative effectiveness of greenhouse gas in trapping the heat over a certain time horizon. So as mentioned, CO2 GWP is 1. So that means that in the 100 years, it will have a mass basis of 1. So if we compare it with, for example, nitrous oxide, which GWP is 273. So that means 273 kilograms of CO2 is GWP is equivalent with 1 kilogram of nitrous oxide. So that indicates that its radiative effect on a mass basis is 273 times higher than CO2 over the same time horizon. So greenhouse gas emissions are discussed in terms of mass of carbon dioxide equivalent, and this could be multiplied by the mass of emissions. Since 1750, atmospheric concentrations of greenhouse gases have increased, and quite significantly, as you can see, by 120 to 260%. So levels unprecedented in the past 800 years, which we can monitor through the excavations and investigations of the ice on the glaciers and in the South and North Pole. So before the Industrial Revolution, the concentration of CO2 remained around 290 parts per million. And you can see that in 2023, the concentration increased above 400, so approximately 420 particles per million. So quite a lot. And you can see that it was also approximately like 0.5% increase on the annual basis. So 0.5% may not be seen as much, but doing 0.5% every year, it's quite a lot if we calculate the 150 or 170 years, which from the Industrial Revolution, where we started to use fossil fuels in much bigger extent. So the main sources of greenhouse gases, anthropogenic sources, are primarily fossil fuels for combustion. A big part comes also from iron and steel production, cement production, natural gas systems, and so on. For example, United States oil and gas industry emits 2.3% of its gross natural gas production annually. This is equivalent of 13 million metric tons of methane. So much more than estimated by the Environmental Protection Agency. So we have a lot of carbon emissions which we are not even aware of and which we don't measure yet. So we are emitting huge amounts of carbon, and in reality, these amounts are even much bigger. So that's why it is so important to be able to assess them and to monitor them. Methane and nitrous oxide are emitted both from natural and anthropogenic sources, so like livestock, landfills, and so on, and agricultural soil management, like fertilizing and so on. Hydrofluorocarbons are the fastest growing category of greenhouse gases, and those are used mainly in refrigeration. So usually like air conditioning and so on. And those are actually like a super greenhouse gases, meaning that their GWP could be 1,000, 2,000, or even 10,000 times higher than the one from the CO2. So here you can see the main greenhouse gases and the table. You can see the carbon dioxide, pre-industry concentration and concentration in the last years. We can see the GWP and the main human activity source of it. So carbon dioxide, like mentioned, fossil fuels, cement, and land use change. Then we have methane, which is GWP is from 21 to 30 times higher. It depends from the methodology and the source that you're using. It is also like fossil fuels, waste, livestock, and so on. Then we have nitrous oxide, which has GWP 273. It is caused by the fertilizing industrial processes and so on. And here below we have those refrigerants, so super GWP. So you can see that even up to 7,380 times higher than carbon dioxide. So that means that 1 kilogram of this gas causes the same impact on the environment as 7,380 tons of carbon dioxide. So we can see that the carbon dioxide itself, it's not harmful for the environment. We have it if we drink Coca-Cola, if we drink mineral water, we have carbon dioxide inside it. So it is not harmful for us, for human health directly. The tricky part is when the concentration in the atmosphere goes too high. So when talking about the carbon footprint, we have different measures how to monitor it and how to assess it. So the greenhouse gas protocol, which is now the let's say prevailing methodology how to do it, divides emissions on 3 scopes. So you can see on the picture there is scope 1, scope 2, and scope 3. So what is this all about? You can see scope 1, if we start with the scope 1. Scope 1 are actually direct emissions. So those are the emissions from the company facilities and from the company vehicles. So that means if we produce something if we are producing, I don't know, some kind of iron products and we are having some emissions directly from the company, this goes to the scope 1. There are company vehicles, so if we want to deliver our products with the company vehicle, so the company truck or something to our final customer, that goes to scope 1 emissions. Then we have scope 2 emissions. So scope 2 emissions is the purchased energy, like heating, electricity, steam. So that means if we use electricity in our production, we don't need to produce this electricity by ourselves, but we can buy it from, for example, from the market, from the grid. That means we are not directly causing this impact on the environment, which is caused, for example, in the power plant, which is creating or which is producing the electricity, but we are spending this electricity. That's why it is included in our in our carbon footprint. So you can see that this is the scope 1 and scope 2. So everything what we emit, everything what comes from the driving, delivery with company vehicles, and all the electricity, heat, steam that we buy on the market. So this is actually obligatory part for reporting from the companies. You can see it here below. Reporting companies must report scope 1 and scope 2 obligatory. And you have also very clear rules about that. Then you have the scope 3. So scope 3 are some kind of indirect emissions. You can divide them on upstream or downstream activities. So this is again the transport and distribution, but in this case, the transport and distribution, if we have some, for example, third-party logistics. So we have a logistics provider that takes care of the distribution, that will deliver our product to our final customer. So that's not a part of our company carbon footprint. It's actually a part of that delivery or logistics company carbon footprint. However, we can still calculate it because it is actually caused by us. Scope 3 means indirect activities, indirect emissions, and this is a part which companies are do not have to necessarily report in the same way as scope 1 and 2. It is also, if I go on a business trip with my personal vehicle, that goes to scope 3. So if I take company vehicle, that goes to scope 1. If I take my personal vehicle and I go to business trip in Vienna, for example, I will drive there and back. I will get cost reimbursement, but emissions are included in scope 3. So this is use of sold products, for example, end-of-life treatment, employee commuting, as mentioned, business travel with airplanes, for example, and so on and so on. So quite a lot of Scope 3 emissions could be expected, especially in the service companies. So if we have a production line, Scope 1 and 2 are prevailing. If we are having service company, for example, Scope 3 is prevailing. So we calculated, for example, greenhouse gas emissions and carbon footprint for our faculty, and we found out that, for example, we don't have Scope 1 emissions, more or less we don't have them at all. We don't have company vehicles, we don't have any production or company facilities. We do have Scope 2 emissions because we buy electricity, we buy gas for heating and so on. And we have quite a lot of employee commuting and business travel, so Scope 3. And this is what's interesting because carbon footprint calculations are actually helping you to monitor and to assess emissions, but you must be aware what to do with the results. So you must be the expert, or you must be a professional to be able to interpret the results as well. So the main sources or main environmental impacts are the resource extraction, energy use, and at the end, wastes. Yeah. So determining the carbon footprint is only a prelude to emission reduction planning. And this is overall a purpose of contributing to reduction of environmental impacts. So companies want to reduce environmental impacts. By calculating the carbon footprint, companies can obtain the necessary information to help them to reduce this. So they can control emissions over the time, they can control their carbon footprint, they could accurately report and meet requirements of, for example, of legislation, for example, of business partners, for example, of investors. It also enables their customers to choose more environmentally friendly products, for example. They also can get necessary data or information for decision making in procurement, in selection of material, in production development. They can confirm that they are socially responsible, and it can also bring them competitive advantage. So how exactly? If you have, for example, one big company is your strategic customer and buyer, and this company is a big company, for example, let's say big producer of vehicles like Volkswagen, and they are cooperating with one small company in Slovenia which is producing one part for vehicles. So the small company in Slovenia does not require to do carbon footprint monitoring. Volkswagen, on the other side, is a big company, so they need to do the sustainability reporting. And because if Volkswagen or the big companies want to assess their carbon footprint, they need to get the impacts from their suppliers as well. So that's why this small company will need to provide the data and information about their own carbon footprint. Even though they don't have to do it by the legislation, they will have to do it because of the requirements of business partners. So that means if they will not do it, they will not be able to remain the supplier of this company. So that's why I'm thinking about the competitive advantage with this, because if someone will not do these calculations, then the big customer will have to replace them. And all of those who will do that, who will prepare the calculation of carbon footprint, will have the competitive advantage to replace those suppliers. So as mentioned, it is about greenhouse gases, CO2 emissions through different stages of the life cycle. And this is the carbon footprint. We can do also the monitoring, or we can do the assessment on different types, for example, more comprehensive. We can assess the human health, like carcinogens, VOC, respiratory inorganics, radiation, climate change. We can assess ecosystem quality like ozone layer, ecotoxicity, acidification, land use, and we can assess impact on the resources. So all of these are the more comprehensive assessments, like the life cycle assessment. We will also talk about that in one of the next lectures. But as we talk only about the carbon footprint, we can see that this is only this, we are covering this part. So carbon footprint is great for let's say initial for initial insight on the emissions, on environmental impacts. However, it is sometimes hard to say whether one product or one company is more or less environmentally friendly if we only compare them by carbon footprint. Because we don't know how much water they spend, we don't know how much land they use, we don't know how much respiratory organics they leave, and we don't know anything about radiation, acidification, ecotoxicity, and so on. So let's go on the calculation now. So you can see here the QR code. I hope it will remain operative and that it will be working. So we will go on the carbon footprint calculator to calculate the emissions and to show you how this can be done very easily with the help of free available internet tools. So I have opened it already here. So just a moment. Okay. So the easiest way how to do it is to just Google carbon footprint calculator. You have quite a lot of different calculators. You can see it here. You have it for the personal use. You have those for the business use, and so on and so on. I will show you how to calculate the carbon footprint on two calculators. So we will start with that one. And here you can see you can see this one. So we will do it from the beginning. So here is the initial question: how big is your footprint? So I will take the questionnaire. So the first question you can see is related to food. So the food is what we eat is very important from the perspective how big impact we have on the environment. So it depends whether you are a heavy meat eater. If you don't eat meat very rarely, you're vegetarian or vegan. So let's make it that we eat meat very rarely, and let's continue. So it is also depends, our carbon footprint depends, for example, on the individual basis, whether we cook ourselves, whether we buy outside at the restaurants, and so on and so on. In the canteens, do we use spend a lot of money for takeaways and so on. So if we don't eat in restaurants or canteens, or we don't use takeaway, we cook always by ourselves. So we don't spend anything for the food. If we do eat outside, let's say that we spend around 30-40 units per month. Another question is what we do with our food. So if we produce food, if we cook food, if we eat food, or we throw it away. So how much of the food that we buy and cook is thrown away? So from my perspective, I'm quite quite rational here. So we really don't throw food away. No matter that, I was making calculations how much food waste we have, and still we are on around 10%. So just the peels or some waste part of the vegetables or fruit or something like that, eggshells and so on. So it is still quite a lot of food that goes away. So it's not edible, we cannot eat it, but something could be done out of it if we would integrate circular economy principles. So let's say 10 to 10% approximately. And it depends also whether you buy food from which is locally produced or you buy food which is more which is imported from and you like to eat strawberries in the middle of the winter, and of course then this makes much bigger impact. So for me personally, a lot of food I buy is locally sourced. If you don't worry where the good food comes from, you just answer by the different answer. So what kind of vehicle you travel in most often as a driver, as a passenger, and so on, is if you want to give more information on the public transportation, you can see that you have it in the next question. So let's say that we use a lot of public transportation. So here is the question whether you use train for commuting. For example, I do use train because I go to work by train. So I spend approximately 6 hours a week with it on a train, even more sometimes. I don't travel by bus because I don't have good connections with the bus. And here we have return flights. So flying is one of the ways of one of the biggest impacts also on the environment from the carbon perspective. So we can see how much are the domestic flights. So this is for the UK calculators. So domestic flights are calculated on the UK case, but we can do it on a basis of to from Europe. So all the travels within the Europe. So I can say that I have traveled, I think twice last year within the Europe, and I was having one flight from outside the Europe. Actually, there were two, so like that. And we go to the next question. So what percentage of your flights do you offset? So what is flight offsetting? This is if you pay additional amount of money, for example, it is offered by different airlines where you can donate some money for the emission reductions. So I usually don't practice that. So like the majority of people don't. And here is what kind of house you live in, whether is it a detached, semi-detached, is it a flat, or what kind of house it is, and how many bedrooms you have. So how many people lives in your house. So only you can see only age 17 and above. This is a little bit strange to add, but this calculator just doesn't consider children. So let's say 2 adults, and how do you heat your home? With gas, oil, electricity, and this calculator then calculates the impact you cause with the wood or with the heat pump. I have a heat pump. So there is a question if your electricity is on a green tariff. So if you have a solar power plant, it's yes, it could be 100% or maybe something less. If you don't know, you just click don't know. For example, I know that I'm having the solar power plant, so I have it 100% renewable electricity. Do you turn off your lights frequently and your appliances? Or not? So depends on yourself. So you just take the question by yourself. How warm do you keep your home in winter? So we have approximately something above 21.5. So the top question you can see, and which improvements I you having in your home. So I'm having more or less a new building, so it is more or less everything like that, we can say. So it depends, you just calculate it by yourself, and you can see then what is going on. So we calculated now for the food, we calculated for the travel, we calculated the impact from home, and now we have stuff. So as being the big consumers, we are also causing big impact by consumption. So here are the questions related to our consumption. So which things we bought in the last 12 months, household items. So I bought some furniture and I bought a new tablet, I think. So let's go on the next question. In a typical month, how much do you spend on clothes? So all of those who like fast fashion, don't be shy, just give the right answer. It is not about giving wrong or right answers. It is more about getting the information about your impact. So whether it surprises you, whether you expected it to be so low or high, let's wait for the results. So I usually don't spend much on the clothes and footwear, so let's say 50-60 euros per month. And how much you spend on pets. So interesting question. So if you have a pet, if you spend something for a pet, for the food and so on, you must be aware that this also causes some environmental impact. So that's why I was saying at the beginning, the calculator only includes adults, so 17 or above, but it does include pets. So it's a bit tricky. So you can see the different calculators are giving you different insights into the carbon footprint. So let's say that I have a pet, I spend some money on it, of course, health, beauty, and so on. So hairstyling, sunbaths, manicure, and so on. So whether you do it or not, depends on you. Then we have the biggest cost usually recently. So phone, internet, TV. So this typically accounts for approximately like 60 euros. And entertainment, so hobbies, sport, gym, cinema, gardening, computer games, newspapers, and so on. So let's give some meat amount. Here we also have a question, what type of waste do you recycle at home, or if you do compost? So which type of waste do you recycle? More or less quite common is to compost the food. All the rest, I don't have the ability to do that. Then you click finish and wait for the results. So whether you are based in the UK, I'm not based in the UK, so get the results. So based on our calculation, you have seen what we have calculated, and here you can see, oh no, you're over the target. Your annual footprint is above the UK target. So we can see what was happening, and no matter that I'm having new house, I'm having solar photovoltaics, I'm having good insulation, I don't eat much meat and so on, I am composting food at home, I'm still having huge carbon footprint. So twice as big as the UK average, for example, or even almost approximately 3 times as big as the world average. So it is quite a lot. So if you want to break it down, you can see which are the biggest impacts, and you can see that for me, the biggest impact is traveling. So as mentioned, I was having 2 flights two international flights from outside Europe and a few flights within the Europe. So you can see that I don't have big amount at home. I don't have big amount on food or stuff, but huge amount on traveling. So if I would stop traveling, I could do a big impact. So you can see here, how is your area doing, and so on. You can see here, okay, this is my hotspot, how to reduce it. And you can see here the proposals, how to reduce it. So drive smarter, what to do, remove excess weight, correct air pressure, drive slower, use public transportation, travel on bike, and so on and so on. So the most important one, challenge yourself to make a difference. So let's challenge yourself to make one flight less a year, or make one train ride more a year, or let's replace car with bicycle once a month. So this is how it could be done. So you can see and you can get your results, and you see that you can get really interesting, really interesting results. Let's go on another one. So here is another calculator, here is another calculator, and I will show you also another one, which I prefer. So this is the carbon footprint, the trademark also. So it is also enables calculations for the business sector. So you have the carbon footprinting, you have the verification as well. You can set the targets, you have supply chain footprinting, and so on. So it is a little bit more advanced than the previous one. You can use it also, the new one, the Sustrax Vita. So it's a little bit different. You can try this one as well. I would like to show you this one. So you can see the impacts which are calculated. So you have the housing, you have flights, car, motorbike, bus and rail, and secondary. At the end, you will get the results. So why I think this one is better? Because first of all, you choose the country you live in. So why you choose the country you live in? Because choosing your country allows you to compare the carbon footprint with the average person in your country. Because for the countries, the web page can use accurate information for electricity generation emissions, for gas and electricity, and whereabouts you live. So it depends whether you use electricity in Slovenia, whether you use electricity in India, you use electricity in UK, and so on. It has different environmental impact. Then you write down the period of time you want to make the calculation for. So mine is for example, for 12 months. So let's say for 2024. And then we can continue and go on the house. So here I put in the numbers. For example, if you, I don't know, depends how much electricity you spend. So you can use your electricity bill, just use that number. So it is the same in companies. If you want to do the carbon footprint calculation, just use the numbers available. So I'm not spending much electricity. As mentioned, I have my own power plant. So let's say that I spent approximately 300 or let's say 350 kilowatt hours per month. So this is yeah. Well, here you also have to number how many people live in your household, and you can see the amount of electricity. So we have per month, so let's say 4,000 kilowatt hours per year. So this is the factor. So you can change the factor if you have the factor for your own company. So some electricity providers have included this factor on the bill. So you can write it down and you can say you can get the exact amount of your carbon footprint from your supplier. So it depends whether the electricity is from nuclear, from hydro, from solar, from coal-powered power plant. Then we have the heating of the house. So I don't use natural gas heating oil and wooden pellets. I just wanted to show you how it works. So if we calculate the household footprint, we can see, for example, that we have 360 tons of CO2 equivalent for electricity. So this is 1/3 of the electricity, because I numbered here number 3. So 3 people, that means each one of us accounts for 1/3 of it. Then we have different types of heating. So at the beginning of the presentation, I gave you the representation of 2000 liters of heating oil. So 2000 liters of heating oil is to 20,000 liters, 20,000 kilowatt hours. So how you do it? You can just use the AI for the calculation. So you can see how many kilowatt hours gas equals 2000 liters of heating oil. So you can see heating oil, 2000 liters of heating oil times 10 kilowatt hours per liter. So that means you have 20,000 kilowatt hours of energy, heating oil. So you can equal that with natural gas, you can equal that with LPG, you can equal that with approximately, you have it here, for example, 2000 liters of heating oil is roughly 4.17 metric tons of wooden pellets. So use AI to help you. Wooden pellets, and you have the calculation. Here you can see what are the differences. You can see that the biggest impact on the environment has the heating oil, 1.65 metric tons. So that means 1,650 kilos. Natural gas is already much better, so its impact is approximately 30% lower. And if you use the wooden pellets, as mentioned already before when explaining the carbon cycle, the wooden pellets are made of wood. So that means that they are close to being carbon neutral. So it does cause some impact on the environment, but if you are heating your house with the wood, you are not causing big harm from the perspective of carbon footprint. That's why I was explaining before. For the carbon footprint, there is a bit tricky, and for all the rest, not that tricky. Then we go for the flights. You can go on the return trip. You can have direct. You can more specificate better where you want to fly. So, for example, let's say no, not Japan. I went to. Okay, let's put. We don't have Delhi. Okay, there, I will just put that one. Sri Lanka economy class, how many trips? So you can calculate and add. You can see 2 metric tons. So here we were having heating, for example, with natural gas, heating oil, and wooden pellets. So the same amount, more than we would, bigger amount of carbon footprints that we would cause with heating oil, we are causing with, for example, to keep up with the calculations, offset, oops. Okay, so bigger impact just because of one flight. So my second flight was from Zagreb, and we went to Portugal. So let's do it like this, so we can see what kind of what is with the flights within the Europe. So much less, but once again, big amount of CO2. Then you go to the car, you can exactly specify how many mileage you do, what's exactly the car that you are using, what's the manufacturing date, or what kind of car, I don't know, you have, just make it up one. for example, one car, and what is the efficiency? Let's say we have a lot of diesel cars in Europe, so okay. So we do it like this, and we have 2 metric tons. So the annual driving with a car for 15,000 kilometers is the same as, let's say, one flight from Ljubljana to India, from Slovenia to India. So motorbike, I don't use motorbike. So if you do use motorbike, you can put it on, otherwise not. Bus or rail, you can use and write down maybe how many miles you do on the annual basic, and how much kilometers you do with the train. So with the train, I do quite a lot. Let's do like that. Subway, maybe something with a taxi, and you can calculate that as well. So you can see if you can also try to make calculations like this, and you can see how many what are the comparisons. For example, you can do it like this, and you can see traveled by taxi is the same as the personal vehicle, like the previous part, and subway, train, bus. You can see what are the differences, and we can see how much smaller our impact is if we travel the same distance with the train instead of taxi or personal vehicle. So we can remove that or just keep it here. I will do it backwards. So like this. Okay, we remove those. I just wanted to show you. Okay, calculation. Then we have the secondary impact. So the secondary impact, what that would be, the secondary impact. So if you continue with the secondary carbon footprint, so these are all the relevant categories you can see on the screen, which also cause some carbon footprint. But like mentioned at the beginning, there are scope 1, scope 2, and scope 3 emissions. So these secondary are actually the scope 3. And here you can see I just put in some values. For example, you can choose first you can choose the currency. I'll put euros. You have the diet, if you are a heavy meat eater, medium meat eater, vegetarian, or so on, just eat fishes, and how much money you spend per year. You can also do it per weekend. It will calculate it for you. So let's do like 50 euros per week. Then you have pharmaceutics, how much you spend for clothes. For example, in the previous calculation, we have the amount per month. So let's do it like that per month. So let's say that we spend 150 euros per month and 50 euros per month for clothes, for example, pharmaceutics, paper-based products like books, magazines, how much we spend for the computer and IT equipment like earphones, smartphones, and so on per year. Then we have television, radio, phone, and so on, equipment, motor vehicles, without fuel cost, of course. So if you are buying new clothes or a new helmet or something like that. Furniture, like I mentioned, I bought something, so it is, I've just put in like 500 euros. Hotels, restaurants, a little bigger amount in my case because of lots of traveling. Telephone, so approximately if there is approximately like 15 euros per month I pay for the mobile phone. So let's say approximately 200 euros per year. or maybe easier to say it like this. So 15 euros per month. So we can give in the exact data from the bill. Then we have banking and finance. We can do again 100 euros like some kind of a evaluation, or we give it per month and we put in the exact number, I don't know, 7.5 euros, or how much you pay for monthly fee for banks and finances. Of course, students have free accounts and you don't pay anything, so you can put here also 0. Fine. Okay. Insurance. If we want to make insurance of the house, of the car, maybe some health insurance or something like that, I put approximately 1,000 euros per year. Education, if we want to go on some conferences, symposiums, or something like that, we can also add this one. So it's also related to traveling and recreation, culture, sports activities like going in theater, concerts, I don't know, in a gym. And we have estimate secondary footprint. Here we have span must be a whole number. Okay, once again, I did the same mistake. Okay, and here we have the total secondary footprint. So approximately same as my total footprint from the transportation with the car, or like one flight from Europe to Asia. So we can see the biggest impact is food and drink products for pescatarian diet. We can add also, you can check and add like for different diets the same amount of money, and you can see what's the difference in the calculation. So we can see that I don't spend much for clothes, for example, 3 times less than for food, and the impact is just twice, just 1/2 of the one from the food. Hotels, also quite a big impact, and something from the furniture. So in this phase, we can go to the final results, and here you can see the final results of yours that you have calculated. So like mentioned, house, flight, car, motorbike, public transportation, and secondary impact. So once again, quite a big impact. So 16 metric tons of CO2, quite a lot above the average. So like mentioned, I was not giving the exact data here because on the previous calculation, we put in 4 flights. Now I put in only 2 flights because there are more exact calculations available, so we can put exact numbers here. We also put different fossil fuels in housing, so maybe a little bit different calculation than the previous one, but even if we would want to put completely the same numbers, we can still have some differences among different calculators. So that's why I like this one better, because I think it is more detailed, more precise. So here you can see again your footprint, country average, world average. So we can see that Slovenian average footprint is 6.78 tons. For European Union, we can see it is more or less the same. Globally, it is a little bit less, so 4.8 metric tons, and the worldwide target to combat climate change is actually 0 metric tons. So we can see how much we have to do, how intensive and how strict we have to be with reducing the carbon footprint if we want to keep our environment as nice as it is and without too significant climate changes. So here you can also see what are the potentials for the reductions. So here you can click on the carbon reduction section. Here you have tips and advice to help you to cut your carbon emission as well as the costs. So, for example, the average family that creates 4 people create 10 tons of CO2 emissions per year. And here you can have the saving actions. For example, top 5 of them are to hang out the washing inside instead of tumble drying. So that's how you can save 153 kilograms of CO2. Turn down the heating by 1 degree. So this will enable you to reduce the energy consumption by 8%. So quite a lot, 8%. And not just reducing CO2, you also reduce your bill if you reduce environmental impact. Then you have only put in the kettle amount of water that you need to boil. You can save additional 72 kilograms of CO2, spend less time in shower, so additional 23 kilograms of CO2. So we all like to be under the hot shower, but you can see that it's a big impact on the environment and also big impact for our wallet if we combine and sum all of those costs together. If you have a lot of electrical equipment at home, try to turn it off. Don't leave it in standby, because if you leave it in standby, it still consumes electricity. So with that, you can save additional 5 kilograms of CO2 a year. So without any big, let's say, big changes or big investment in new technologies, you can save up almost half a ton of CO2 and quite some money. And this is also a very important lesson. So whatever we do, however we try to decrease environmental impact, we decrease also our costs. So the impact on our wallet, to be precise. So saving environment also helps us to save costs. Here you have also the chart of which items contribute more to your carbon footprint and costs. We can check this one as well. You can see different appliances, microwave, washing machine, tumble dryer, kettle, gas oven, and so on. You can see here on the right-hand side, you have the costs per year and the kilograms of CO2 per year. These are, of course, estimations. It's not the same in every household, but you can see which are the most influential. Here you can see also the different specifications, for example, for the fridges. So if you have very, very efficient fridge, you will spend half less money and will create half less emissions than with, for example, fridge with the specification A. So quite a big difference. You can see here also what's the difference among different bulbs. So if you have a standard light bulb like 100 watts, this is now forbidden or not allowed to be produced and sold anymore in European Union, but you can see how much money you spend for it for one bulb, or if you use low energy light bulb. So the 18 watts, if you replace it with some even LED diodes, you can additionally reduce this amount. Here you have, again, different types of televisions and digital adapters in the standby mode. So you can see how much they spend for in the standby and how much, again, this costs you, how much CO2 this creates. So quite a lot of different, useful information. And if we go again on some tips, what to do, you have technology-based energy saving. So feed energy-saving light bulbs, like seen also in the table. LED bulbs can save up to 90% of lighting electricity needed for lighting. Install new technology, insulate your house, water tank, and so on. and replace your old refrigerator. Travel less, travel more carbon friendly. So share car, use bus and train and public transportation, you walk and cycle for shorter distances, try to reduce the number of flights, try to reduce the mobility needs. So try to promote home office, for example. This is also the way how you reduce the carbon footprint, and choose low emission vehicles. When staying in a hotel, very important, turn off the lights and air conditioning when you leave the room, because you will make a contribution and you won't feel the difference when you get back. You also can buy local foods, don't buy local bottled waters, reduce the consumption of meat, buy organic products and recycle as much as possible. And the most important thing, of course, think carefully and put in front of yourself an objective that you want to achieve. So let's say once a week I will travel by train instead of travel by car. Once a year I will avoid traveling by airplane. I will visit, I don't know, European capitals with a train. You can do that. It's not tricky. It's easy, and maybe it will be even nice, and even nicer than with the plane. Avoid over packaged products and so on. So you can do quite a lot of goals for yourself. You have also here the calculator, for example, for plastic waste. You can see that the plastic calculator is one additional tool that you can use for the environmental assessment. So as mentioned, carbon footprint measures carbon emissions. Water footprint will tell you how much water you use, and the plastic calculator will tell you how much plastic you spend, what's the impact what's your impact regarding the plastic use. So there are different types of calculations that you can use, and of course all of them can give us a very valuable insight of what we are doing and how efficient we are regarding the environmental performance. Okay, so if we go back and sum it up all together, so within the whole supply chain, different phases, so manufacturing, distribution, use, sourcing, even in designing the product, there are different types of environmental impacts that are being caused or that they occur. Regarding the carbon footprint calculations that we have done now, if you do it yourself, you can compare the results with your friends, with your family, with your neighbors, and so on. So you can see where are the main differences, what are the best ideas to reduce the impact. You can brainstorm it with your friends as well. So here are some of the ways how to reduce it. So like mentioned already, reduce meat in your diet, avoid wasting food. You can, for example, replace high carbon meat also with the low carbon meat. So that means the majority of carbon footprint in the meat production is caused by beef. So even if you don't want to become vegetarian or vegan, or you don't like that because you like meat, you can just replace meat with beef with poultry, and you will make huge contribution as well. Walk, bike, carpool, use mass transit, or drive best-in-class vehicle. Ensure that car tires are properly inflated, because you can also save some gasoline with this measure. Try not to build too big houses, of course. So average household energy is the highest in the single-family houses. In semi-detached or with houses with more apartments, energy use and impact, of course, is significantly lower. When washing, for example, dishes, use dishwasher, because dishwasher is usually much more efficient than if we do it manually, and we save time as well. get rid of devices that need to use too much electricity in the standby mode. You can also buy these energy meters for 25 euros, so you can measure where you have the biggest energy consumption at home. Choose energy efficient lighting, for example, switch to LED bulbs, for example. When we did it at the Faculty of Logistics, we installed new LED bulbs at our hallways, and we have our return of investment was approximately 1.4 years. So let's say less than 3 semesters. And we already in 3 semesters, approximately less than 3 semesters, we saved more on electricity than we have to pay for the new lighting. So definitely worth of it. Yeah, we can also cover the roofs with some solar reflective material or photovoltaics if we have the chance to do that. Regarding the food accounts for 10 to 30% of household carbon footprints, depends on your diet and of course all other things, how much electricity you spend, how much you travel and so on. So production is the biggest part of it, so 68% of food emission. Transportation accounts for only 5%. So we talked about ordering strawberries from different parts of the world during the winter. You could say, oh, but transportation is not such a big impact. So it's not a big impact when I order strawberries in the middle of the winter. Yes, true. But still, the preparation of this food, packaging, transportation, and altogether, it still causes quite a big impact on the environment. Food production mainly consists of CO2, nitrous oxygen, and methane, which result from agricultural practices. We found out now that meat products have larger carbon footprints per calorie than plant-based products. Mainly livestock, the main contributor is livestock, which emitted 195 million metric tons of CO2 of methane, so quite a lot. Majority, like I mentioned before, 71% from beef cattle. So even if you replace the type of meat, you can do a lot. So vegetarian diet greatly reduces carbon footprint, but even switching from carbon-intensive meat to, for example, chicken or poultry can make a big difference. So to show you the results, not just talking about it, you can see here. Beef, for example, has almost 6 times bigger carbon footprint than the poultry. So much bigger impact. And you can see on the other side that, for example, vegetables, potatoes and so on, have much smaller impact. On the right-hand side, you can see the distribution of the impacts regarding the type of food, and we can see that meat and dairy account for almost 3/4 of it, and the plant-based food with seafood, with eggs, altogether only 1/4. So we all can see very easily how can we replace some food items and how can we very easily reduce our carbon footprint just by making small changes. And these small changes are usually the most efficient. So replacing 1 meal per week with, let's say, environmentally more favorable food is a great way of doing it. And of course, replacing it with healthier food like plant-based food or vegetables is also good for our health. So I hope you liked you liked it. I hope you will be calculating your own footprint and you will make some contribution by deciding for the improvements, by deciding for the reduction. Here you have some additional resources, but I'm also sure that you will find relevant literature by yourself as well. So this is the first one. So what you will be doing is you will perform like environmental assessment of a specific product. So you will first, each team you will write here the names of the team. So you will have like name 1, name 2, name 3, and so on. And you will define here what product or what kind of a process you will assess through this task. So if you will have like a plastic bottle of water, 0.5 liter, for example, then you can use this plastic bottle for the further analysis. So the further analysis, when you have the group defined, and when the group will discuss which product you want to investigate, then you will go on the next step on the assessment details. So you can use the same, let's say you can use the same product or supply chain or something that you will be doing also in the tutorial number 2. So in the tutorial number 2, you will be talking about the added value. You will be talking about the risks, about the supply chain strategies, about the priorities. So more about the business perspective. So the supply chain management business perspective. And in this case, you will be dealing more with the environmental assessment. So for the plastic bottle, for example, here in the assessment details, you will first define what are the product specifics. I can enlarge it a little bit so that you will see it better. So you will first define product specifics. So what is it made of? So it is made of plastic. Plastic is made of oil. So it is a derivative. It's derived from oil, for example. Then you will go to the internet, you will Google how the plastic is made, and you will you will describe the production, how the plastic is made, where the most of the energy is used, where the most of material is used, and so on and so on. So then you will go on the distribution and transportation phase. So what is happening in the distribution, in the transportation? How tricky is to transport the plastic bottles of water? What is the tricky part? What you can do, what you cannot do, what kind of transportation is allowed for the food, what kind of plastic is maybe not available for the food items, and so on and so on. Then you will have the use phase. In case of plastic bottle, use phase is very, very slow and very undemanding, because actually you only need like you can drink water in like 2 minutes, and then you throw the bottle away. So use phase is let's say the least problematic, but it is very tricky from the user perspective side. So how the users see it. So it would be much wiser actually to, as we discussed in the 4R concept, that we wouldn't use like a plastic bottle, we would use tap water. We could reduce the plastic that the plastic bottle is created from. We can, I don't know, increase the recycling rate of the plastic wastes, and so on and so on. So you will explain here in this assessment details each phase of the supply chain, and you will describe the specifics of the product here. Okay. Then you will go to the next phase. This next phase is LIT, so the life cycle assessment tool. So the life cycle assessment tool is that where you will describe, or you will define or divide your supply chain on different phases. So here we have it like a raw material or resource extraction. Then we have a transportation of raw material to the production site. Then we have the production. Then we have packaging, distribution, use, end of life. So this is just one way of dividing the supply chain. You can use it also different
a different way if you want to. If you will say, okay, the raw material, it is being extracted on one point, and on that point it is also being produced. So we will have production of semi-product, for example, product, and then you will have the production of final product. You can do it also like that, and then you don't have any packaging, and here between you have like a transportation, for example, and so on and so on. So you can do it. You will define your supply chain regarding the product that you will choose, and regarding the supply chain, you will identify all the related environmental impacts in each of these phases. So in this phase, for example, you will have like for the raw material or resource extraction for the plastic bottle, for example, for the plastic bottle, which raw materials are being used. So you will have like extraction of crude oil, for example. If you go back to the beginning of the life cycle of certain bottle, then you will have energy. So energy, heat, electricity, oil is being used for extraction. Is there maybe some water pollution in the extraction phase? Maybe there is, maybe there is not. Are there some waste that are being produced in the extraction phase? You have quite a lot of them, so I think you have like a you have some kind of waste in the phase of the raw material extraction. So in the phase of extraction of crude oil, there is some electricity or oil that is being used for the extraction. Maybe there is some water that is being used. Maybe there are some waste that are being created. There are some emissions, for example, of CO2. You have maybe particle matters. You have maybe some emissions of NOx, so that maybe you have some other emissions. So you will write down what is happening in this phase. And then you will also address the social impacts. So whether there is some noise pollution, whether there is some, let's say, forced labor, and so on and so on. So you will define all these for each phase of the supply chain. So each phase of the supply chain for these 6 segments. So materials, energy, water, waste, emissions, and social impacts. When you will fill the whole table, you will do this table and you will say, okay, there are numerous environmental impacts, but we have limited resources, so that's why we cannot address them all. So we can address only the most important ones. So we will try to define which are the most important. And you will say, okay, let's say that this one is one of the most important, and let's say noise and pollution, or I'm just making it up just to show you, so it's not the right. So out of the whole table, maybe you will have some free spaces. Maybe you won't have any in the transportation. There is no water pollution. Maybe in the use phase there is no water pollution. So you just assign it like this, or make it not available, or something like that. If there is any phase that it doesn't have any impact, and then you will extract, or you will define the hotspots. You will define the hotspots. So which are the, let's say, 2, 3, or 4 hotspots from the whole table, and these hotspots you will put them in here. So let's say you will do it like a noise pollution, and you will put it here, noise pollution, forced labor. You have it here. So heat, electricity, oil is being used for the extraction. You have the second one, and then you will you will define the design focus area. So the design focus area is in both cases is the first one, so the raw material extraction. So you have it here, the design for material sourcing. So you will define which phase is the most important to improve. Design for material sourcing, and in this case, it is the same in both cases. So you will have the hotspot 1, hotspot 2. Both of the times, its design focus area is designed for material sourcing. So this is the first phase. Then you will try to do it a little bit differently, so a little bit more systematically. So you will go to assess the potential options by using the eco design checklist. So what you are gonna do, you will do this kind of you will prepare this spider diagram actually, where you will define the current state and you will define the potential for improvements. And here you will use the second document that I sent it to you. So you can use the eco design focus area table. So you have it for design for material sourcing. You can use this one too. You can see it, it's a red color, so you can use it to assess the current state. You have it in the second document. You can see here in the current state, you use the red color. For the potential for improvement, you use the green color. So you just draw it in here. So you will get like a figure, something like that. So you will get it something like this. So the red one is the current situation and green one is the potential for improvement. And then you will assess where is the biggest gap. You can see it, the biggest gap is here. So that means if here is the biggest gap, that means that this phase is designed for the end of life is actually the biggest, the most potential area for improvements. So you can do it to assess the current state. You can use this this focus area table. So you have it like for design for material sourcing. When you specify materials, do you consider their impact on the environment? Do you relate it with volume, weight? Do you use recyclates? Do you consider the embedded energy in water or not, or yes? So here you have some environmental benefits and businesses. So you can just describe it, whether you are doing this, could this be useful? Is this appropriate for your product? Yes or not? So to go through a little bit through the whole life cycle. But then I recommend you to do this spider diagram by the second part of this document. So the eco design checklist. So you have it here to assess the current and the potential state. So what you should do is actually to start considering if you have, like, for example, if you have plastic bottle, are you reducing weight and volume of product? Currently, we are not doing anything. Is there potential to reduce weight and volume of the product? Of course, it is potential. Maybe we can reduce the plastic that is embedded in the plastic bottle for 20%. So that means the potential is, let's say, you can assess it from, you can see it 0 is no, 1 is partially, and 2 is yes. So the potential is big. Then you can try to consider, are you increasing the use of recycled materials to replace the virgin materials? If you're not doing this at the moment, or you're just partly doing this because, I don't know, the cap for the plastic bottle is made out of the recycled plastic, so you can do it, let's say you can do it like this, and you can say, okay, partly it is done already, but not yet fully. It could be done completely. So you assess this for all these phases, and to all the you go through all of this, and then you calculate. You can make the remarks. You can say here, okay, currently the cap is made of recycled plastic. Potential is to for example, something like this. So you can write down the remarks. And then out of these numbers, you will assess what's the current situation and what's the potential for design for material sourcing. So you will calculate all of these numbers and you will divide them by the number of options. So you can see it here. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 options. And you have, like, if you have, here you have it for as an example. If you have 4 out of 10 options already being realized, that means that you can evaluate this as with number 2. So the spider diagram, you can assess it by number 2. So this is 0, 1. This is 0 is here in the middle. This is 1 and 2. So you make a dot here in this point. And that's the way you do it. If you have like, I don't know, 8 of 10 options is being realized, then you give the value 4. If 10 of 10 is being realized, then you give the value 5, for example. All of the times, the current situation is always, let's say the evaluation for the current situation is always smaller because, let's say, all of the companies none of the companies is actually doing the full potential, are not exploiting the full potential of environmental improvement. So that's why you can first address the current situation and you can address the potential. So when you will define this, and you will get this kind of a spider diagram, you will again have this kind of, let's say, you will be able to assess the gaps. In this case, you can see here is the biggest gap, here is the second biggest, here is the third biggest, and here the gap is not that significant. So in this case, you will define the biggest gaps. So design for focus area, you will say, okay, in this case, you have design for end of life. This one is the biggest. So you will write down here design for end of life. And you will have what is the potential for improvement. For example, you will write down, I don't know, for the end of life, for the plastic bottle, what you can do. So you can check the checklist. And you will check it here. You have it here, design for end of life. You have different potentials here, what you can do. So what you can do here is you can, for example, maximize ease of reuse, disassembling, and recycling. So you will put it here. So this is the option for improvement. And what is some kind of a concrete improved suggestion? So how you could do that? How you could maximize the ease of reuse, so, or recycling or disassembling. For example, one of the cases is that let's say the plastic bottle and plastic cap is produced out of same material. So the plastic for the bottle and the plastic for the cap on the top of it is made of the same material. So if it's all the same material, you can put everything in the same machine for the recycling and you can recycle both of them. If you have different plastic for the bottle and different plastic for the cap, then it's a tricky situation because you have to remove both of them and then you have to recycle bottles separately and the caps separately. So this is the way of doing it. And at the end, you will propose what you are proposing, what should be the next steps of how this could be, let's say, improved in the future, what kind of steps should be taken, and which are the measures that you propose to this kind of a company that is, let's say, in my case, is producing like the plastic bottles. So maybe there will be like a measure, I don't know, replace plastic with let's say virgin plastic with recycled plastic or biodegradable bioplastic. And you can suggest also the steps. So step number 1 is find suppliers of biodegradable bioplastic. Step number 2, supply or not supply, but let's say maybe better to say provide sufficient number of suppliers for biodegradable plastic. Then you have step number 3, modify bottle design to new biodegradable material, and so on and so on. So you can do it. You can, let's say, define it. So you can do it for just for one activity. You can write down 2 activities. So just let's say prepare some kind of action plan. What additionally could be done based on the information that you got from these first steps. So first, as mentioned, you define or you select like one product which you want to use for the further analysis. Then you will assess the details of this product analysis. Then you will prepare this kind of a life cycle impact assessment tool, and then you will fulfill this table. So you have here some empty columns, so you can put it out if you don't need them. You can add additional columns if you need them, and so on. So you will see how your supply chain looks like. Then you highlight which are the hot spots, and define the design for focus area. Then in the next phase, you go to the spider diagram. You focus on the current state and the potential for improvement with the help of this eco-design checklist. So to assess what's the current situation, what is the potential, and then when you see when you get this spider diagram, you will assess where are the biggest gaps, and you will define the priorities. So where the biggest gap is, you will define which design phase has the biggest priority out of these 5 design stages. You will say, okay, design for end of life, design for use, for example, and then you will define the a specific activity which could be done, and you will define the specific way how this could be done in the future. Okay, and then last phase, you will propose the next steps, what kind of actions could be done, what are the suggested steps to make this in the future.